Question says this, that if R is transitive, then show that P is transitive. Okay. Now, how do we start it? We just write what is given to us. R transitivity, that is for all x, y, z belonging to capital X, XRY and YRZ should imply XRZ. This is your R transitivity, that is XRY and YRZ would imply XRZ. Okay, this is R transitivity. What do we need to prove? We need to prove that P is transitive. So we need to prove this, that XPY and YPZ should imply XPZ. So how will you prove this? That you just pick up any triplet from the consumption set X. So you have chosen any three XYZ from this consumption set X, and you just suppose this, that this statement you have to prove. Okay, so you have to prove this statement, that is XPY and YPZ should imply XPZ. This statement you have to prove. So you will just assume this part of the statement, that is your antecedent part of the statement, to be true, and then you will prove the consequent part. So how do you do this? Suppose XPY and YPZ are true. You just assume this, that XPY and YPZ are assumed to be true. So XPY would imply XRY and not YRX. Why? By definition. Okay, that is by definition it would imply that if X is strictly preferred to Y, then this would imply X is at least as good as Y and Y is not at least as good as X. Similarly, YPZ would imply YRZ and not ZRY. That is again by definition. So you have just written the two definitions. Now just try to combine XRY and YRZ. Just combine this. Combine this XRY and YRZ. This should imply XRZ. Why? Because R is transitive. It is given to you. It is given to you that R is transitive. Why? Because it is given to you here. Suppose R is transitive. Okay. So XRY and YRZ have implied XRZ. Okay. See, you need to prove XPZ. Okay. XPZ. Now XPZ should imply XRZ and not ZRX. Okay. Now you have already proved XRZ here. Okay. Now you have to prove this part. So how will you prove this part? That is not ZRX is true. We will prove it through contradiction. Okay. So we will be proving it through contradiction. So what is the contradiction of not ZRX? ZRX. So we'll assume this contradiction to be true. So ZRX is true. So suppose if ZRX is true, you have how many things which are true out here? As you can see, ZRX is true, XRY is true, and YRZ is true. So you'll have to form one example in which there will be some logical contradiction which will come up. So let me pick up ZRX and XRY. Okay, so I have picked up ZRX from here and XRY from here. Okay, and this will give me ZRY. Why? Because R is transitive. It is given to us that R is transitive. Okay, now can ZRY be true? Just see that. Can ZRY be true? You have assumed not ZRY to be true. So ZRY and not ZRY can't be true at the same time. Okay, so our initial supposition is wrong. Our initial supposition is wrong. Hence, not ZRX is true. So you have proved both things. You have proved XRZ and you have also proved not ZRX. Okay.